Hi, I'm Vincent and I'm part of the student team Elara Aerospace. You can see it here. We want to be the first student team to launch a Methalox rocket beyond the Kármán line. The Kármán line is that barrier at 100 kilometers, that barrier between atmosphere and orbit. No one's ever achieved that yet, so this is what we're aiming for. About us. We are based in Munich. We have different students from different universities like Technical University of Munich, Hochschule München, LMU or Munich Business School. We originate from boring innovation in tunneling. Back in the day, we used to dig tunnels. We also participated at Elon Musk's Not the Boring competition in the US every year. And yeah, we actually won most of those competitions. So we said it's time for a new challenge, and this is space. You might ask yourself what differentiates us from other student teams focusing on rocketry. In total, it's 4 different points. Additive manufacturing, so 3D printing. Reusability, we have a rescue system in our rocket, so we are able to refurbish and in the end use our rocket again. A high launch cadence, we are thinking of launching this rocket not once, but a couple times every year. And in the end, the cost efficiency. You know, as a student team, we do not have the biggest budgets, so we need to be as efficient as possible to make sure this project will work in the end. For our flight trajectory, just so you can imagine a little bit better, we will start here at land and we'll have our burnout phase until kilometer 20. At this range, all of our Methalox, all of our fuel is going to be burned. So Methalox is our fuel mixture for liquid methane and liquid oxygen. With current calculations, we'll probably reach an apogee of around 130 kilometers. At step 4, we are going to reorient our rocket so it's facing with the nose to the top. And 5 kilometers above ground, we plan on deploying our parachute to really have that rocket land smoothly on the ground, or in this case, on the water. We will have a water splashdown, which means after the rocket has landed, we'll drive out with our boat and go pick it up again. We are going to launch from Sardinia because one of our sponsors, OLM, is providing us with the necessary launch facilities there. So more of those technical details. What is this whole rocket about? In the end, we'll have a length of 10.5 meters, a diameter of 450 millimeters, and a total weight of 1 ton. But I'll have to say around 720 kilograms of that is going to be pure fuel, so our Methalox, which means the rocket is actually kind of lightweight, but I guess you can argue about that. In the end, we'll achieve a payload of around 50 kilograms, so that's additional weight we can take on which we can take with our rocket to space. This could be experiments for academic institutions or microsatellites even. Our rocket engine is going to be 100% 3D printed. We use a material called CCZ, which is a copper chromium zirconium alloy because of its heat resistance. A further heat resistance, or a thing we have to prevent this whole project from melting down, is our cooling channels, which you can see here. Basically those gray lines which are in a spiral around the bell nozzle. So it's a standard in the aerospace industry, but I'm glad it exists because otherwise our nozzle would completely melt away after a few seconds. We have really, really high temperatures in there, a couple of thousands of degrees of Celsius. So we take a part of our cryogenic stored Methalox, so the fuel we use. In order for those gases to be liquid, they need to be cooled down a lot. So we have these cooled down liquids flowing through those cooling channels and in the end make this whole structure stable. Another part is our RCS, reaction control system. Oftentimes student teams have the problem that their rocket will start spinning. We have this measurement in order to prevent that. We have little holes here at the side, and you can think of it as pressurized air being blown out from the sides of the rocket to keep the rocket stable at all times. Another interesting fact about the rocket is our payload bay. So this is going to be made out of GFK, so glass fiber, because it's a solid and it can withstand a lot of friction and temperatures. So, about the long-term vision which we have here. This is going to be Project Starbound. As I said before, we want to reiterate the whole rocket launch, make little adjustments and make this rocket as efficient as possible. In the end, we will come out with Project Starbound. This is going to be an orbital rocket which is capable of flying to around 500 and 600 kilometers, basically where all of common satellites are. You can see the rocket engine here is basically what I've shown you before for the smaller rocket, but just multiplied by 9. So the small project we are starting right now, which is actually in the making, is going to play an essential part of the long-term plan we envision. With that, we could really transport anything to space. It could be astronauts, it could be commercial satellites. The plans are not set yet, and we are open for anything at this point. So our sponsors, our partners who are supporting us at the moment, you can see it's a lot of software like ANSYS or Autodesk, which we use for simulations. But of course, some more known companies like Linde supplying us with the fuel we need for the project. Different partners in additive manufacturing, so 3D printing, Formlabs, or Xometry, which are providing us with different 3D printers and of course the materials to print with in the end. So I'd say we're a pretty cool group of people. We attend a lot of events, talk to many different sponsors, talk to new recruitees, people like you who are needed in this project, because I'm saying this project is in its earliest steps. It's in the earliest phase, and for that we really need every helping hand. So be it in operations, talking to partners, keeping those relationships with them, or be it in tech, building different things, doing simulations about the different subcomponents of the rocket. Really, there's a lot to do, and this is exactly why we need you. So with this QR code, I'm not sure if it's scannable online, but there you will be guided to our website. We are actually recruiting at the moment, so applications are open. If you're interested in joining this dynamic team, in joining Elara Aerospace, we'd be glad to see many of you in the applications again. And I'm telling you, if this works out the way we are planning it, we are going to write history. As the first student team to launch a rocket beyond 100 kilometers, and especially that timeline, what we're aiming about. I think I haven't mentioned that yet, but we really strive for an ambitious timeline. It's not like with other teams where you wait for like 6 or 7 years until a rocket is finally developed and built and ready to launch. You can expect this rocket, like you see it here, to be launched within the next 6 to 12 months. So I believe this is a once-in-a-lifetime opportunity. This is also why I am part of Elara Aerospace, and I'm looking forward to getting to know you.